Hello everyone and welcome to this tutorial on a solid principle in Flutter. I am excited to take you through the essential coding principle that will help you write a clean, maintainable and scalable Flutter application. In software development, as our project grow larger, they also grow more complex. Without proper structure or organization, the code becomes hard to read, test and modify. This is where solid SOLID principle comes to the rescue. In this video, we will explore what solid principles are, why they matter, and how to apply them effectively in your Flutter development workflow. By the end, you will have a better understanding of how to write code that both professional and future-proof. Stay tuned until the end of the video to discover an important key takeaway that could make all the difference. Don't miss it. Let's dive right into the solid principle. What are solid principles? Solid is a set of 5 design principles introduced by Robert C. Martin, who is also known as Uncle Bob. These principles are not specific to any programming language but can be applied universally to help developers write better code. The main goal of solid principle is to make your code easier to read, test and maintain. Now, why this is important? Well, poorly structured code can slow you down as you try to make change or add new features. Solid principles address this by promoting practices that enhance readability, make the code easier for you and your team to understand, improve scalability, allowing your project to grow without major disruptions, encourage flexibility so your app can adapt to change easily. In short, solid principles are like guidelines for writing high quality code that stands the test of the time. So let's break down what solid means, starting with its acronym. The term solid is an acronym where each letter represents a key design principles. S stands for single responsibility principle. O stands for open closed principle. L stands for Liskov substitution principle. I stands for interface segregation principle. D stands for dependency inversion principle. Together, these principles form a foundation for building well-structured and maintainable software. In this tutorial, we will discuss each of these principles in detail using examples from Flutter development to make them practical and relatable. Now let's go through all the terms. The first principle is Single Responsibility Principle or SRP for short. This principle states that a class should have only one reason to change. In simple terms, each class should focus on doing one thing and doing it well. Here is an example in a Flutter. Let's say you have a class that handles user authentication and also saves user data to the database. This violates SRP because the class has two responsibilities, authentication and database management. Instead, you can split this into two classes, a auth service class for handling login and logout operations, user repository class for managing database interaction. By separating these responsibilities, the code becomes easier to maintain and test. This approach reduces dependency and makes your app more modular. The second principle is the open-closed principle, which says that class should be open for extension but closed for modification. What does this mean? It means that we should be able to add a new functionality to a class without modifying its existing code. For example, in a Flutter app, you might have a payment method interface with a pay method. If you want to add a new payment option like UPI or credit card, you can simply create a new classes that implements the interface without touching the existing code. This keeps your app flexible and reduces the risk of introducing bugs when adding new feature. Next we have the Liskov substitution principle or LSP. This principle states that subclass should be substitutable for their parent class without breaking the application. For example, if you have a bird class with a fly method, any subclass of a bird should be logically be able to fly. However, if you create a subclass like orchid which cannot fly, it violates LSP. In Flutter, you can ensure LSP by designing your class hierarchy carefully and using abstraction wisely. This helps maintain the integrity of your app's behavior. The fourth principle is the interface segregation principle. This principle says that a class should not be forced to implement methods it doesn't use. Instead, interface should be small and specific to a particular behavior. In Flutter, for example, if you have a worker interface with method like work and eat, not all classes may need the eat method. Instead, you can split this into two smaller interfaces. 1. Workable for working relatable methods. 2. Eatable for eating related methods. This ensures that classes only implement methods they actually need. The final principle is the Dependency Inversion principle. DIP states that high-level modules should not depend on low-level modules. Both should be dependent on abstractions. In Flutter, you can apply this principle by using dependency injection. For example, instead of hard coding an email service class into your notification class, you can create an abstract message service interface. Then you can inject any implementation of a message service such as email or SMS. This makes your app more flexible and easier to test, as you can swap out dependencies without changing the core logic. So, how do we apply solid principles in Flutter? Use the single responsibility principle to break down widgets and class into smaller reusable components. Follow the open-close principle when building extendable UI and logic layer. Ensure Liskov substitution principle for custom widgets and interface. Apply interface segregation principle when managing service like auth service and payment service. Use dependency inversion principle with tools like provider or riverpod for dependency injections. By applying these principles, you can build robust Flutter apps that are easy to maintain and scale. To wrap up, there are a key takeaways. Solid principles help you write cleaner, more maintainable and scalable code. Second, this principle ensures modularity, flexibility, and testability in your Flutter project. By applying these principles, you can improve the quality of your code and the overall development process. Remember, great code is not just about making it work, it's about making it work well. Thank you for watching this tutorial on a solid principle in Flutter. If you found this useful, make sure like, share, and subscribe to my channel. If you have any questions or you want to see more tutorials like this, let me know in the comment box. Until next time, happy coding!